So in the other session, we discussed a number of issues on mobile application development. We discussed about all the way from platforms for mobile application development. We also discussed on issues on API, application programming interfaces. We also discussed on a number of testing approaches. So with that, today we agreed we are going to start on Android. So I'll have to share this document on an introductory to Android, which you also have it in your portal, e-learning. So I'll proceed. So to begin with, I want us to learn and understand what is this Android. So Android, as it is, you have come across a number of Android devices. And today we talk about Android smartphones and many other things which comes with Android. We even have today Android watches, smart TVs, which are also running on Android. So as an introductory to this mobile programming, we agreed that we will be working on mobile programming using Android. So Android is a software package and a Linux-based operating system for mobile devices such as computers and even smartphones. So from its inception, we can see that Android is actually based on Linux. We later on see how this Android has grown itself from Linux, and we will be able to see this clearly with Android architecture. So Android is developed by Google and later on by Open Handset Alliance. So in as much as it's developed by Google, remember Android is open source. So it is a contribution of many other parties. So people are free. Yes, members, I think I lost connection. I'm very sorry for that. I think today I've been having a breakdown in challenges of our network a little bit. So I hope we are still together before I proceed. Yes, members, are we still together? Let me know. I've had okay. So I was introducing Android and I said Android is an open source Linux based operating system for handheld devices such as smartphones. So, do you want to share document? So, and I said this Android is actually developed by Google, and later on we can realize that it is being contributed by a number of partners. So Java language is the mainly used to write the Android code, even though other languages exist. So the main language that we use to write Android is actually Java. And the goal of Android is to create successful real-world projects and products that improve mobile experience for end users. That is why Google has given out so that each and every other person can be able to contribute towards the improvement of this Android. So there are names which you must have come across, such as Lollipop, KitKat, Jelly Bean. Those ones are the versions of Android that we do have. Although I know that you should be able to understand that today we are receiving each and every evolution of this Android towards actually focus towards improving features. I don't know what is the current, the latest version of Android. Maybe someone can remind us. Can someone remind us the latest version of Android? Yes? The latest version of Android, anyone? We have KitKat, we have Lollipop, we have Marshmallow, and the others. So kindly find out what's the latest version of Android. Now, I want us to explain this consortium known as Open Handset Alliance. So this Open Handset Alliance, remember I said Google is actually the ones who developed the Android with a consortium of these companies. So Open Handset Alliance is a consortium of 84 companies led by Google. Among them, we have also Samsung, Synaptics, Teleka, eBay, Intel, and many others. They've come in as a group of companies who contribute towards the improvement and ensuring that they drive the vision for this Android, so that they ensure that they're improving features, ensure they give customers experience and the others. So this Open Handset Alliance was established in 2007, and it is committed to advance open standards, provide services, and deploy handsets using Android platforms. That is why today you have even Samsung phone running on Android. I think the other time we saw Nokia, which was running on Windows, though it never survived to see the light of the day. You realize that it just came to the market and disappeared. And you can see the power of open source contribution of many companies, people trying to push in towards one platform that is Android, so that today you can see almost all hardware manufacturers are actually having an OS which is in that regard Android. Of course, there are others such as iOS for Apple, which is solely a product for Apple. It is not open source. And you can agree with me that the power driven by this consortium of companies to realize this Android, you can realize that that is why a number of people are adopting or moving towards Android platforms, because of the contribution that we get from all these major partners. Now, features of Android. One, it is open source, as we have agreed. It's a contribution of this consortium. Again, anyone can customize the Android platform, so you can improve. You have a freedom to extend. It's not like an Apple, for example. Apple is closed or proprietary, so there is no chance of contributing into it. There's also a lot of mobile application that can be chosen by a customer. So out of Android, we can build as many different applications, whether it is messaging apps, whether it is chatting, whether it is any other thing, banking apps, and many others. So we can say that a lot of mobile application can be chosen by a customer. Again, another important feature is Android comes in with many other factors, such as with the details, opening screen, live feeds, and many others. So once those ones are synchronized with the other applications which are working on the Android phone, it gives us a very powerful device. So it provides support for messaging, web browsers, connectivity, media, and handset layouts. We let alone see this in detail or appreciate this one in architecture. So we have a number of Android applications in the market today: entertainment tools, communication apps, productivity, music applications, social like WhatsApp, Facebook, Telegram, and the others, media and video, travel and local, and many others. So we can agree with you today that there is a demand for Android app development. This demand is driven by the number of devices today running on Android. We can agree that we have over 1 billion devices which runs on Android. That tells you that the demand for app development which runs on Android platform is always on an upward trend. So Android surely is an exciting space to make applications, which helps you to communicate, maybe to organize, educate, entertain, depending on the category you want to develop for. So that tells you that you need to appreciate and also learn Android. Again, an advantage into it is open source. So you can just download Android Studio or that development kit, and you can start developing your applications. So that is it. Now, this drives me to understand Android architecture. What makes this Android? How is this Android structured in a sense? So the Android architecture shows us the components that makes up this Android operating system. So the main component here is the Linux kernel. Remember, in the introductory, we said that Android is a Linux-based operating system. And that is why you realize that the Android devices have very high capabilities in terms of network. That network capability is an aspect drawn from Linux. Remember, it is a Linux-based, and Linux as an operating system has very high capabilities for, or wireless capabilities compared even to Windows. So I was explaining about Android architecture, and I said Android architecture is categorized into 5 main parts: the Linux kernel, the native libraries, the Android runtime, application framework, and applications. So this is the architecture I'm trying to explain, considering the 5 main components that makes up this Android architecture. So you realize that to begin with, Android is sitting on top of Linux kernel. So when you're appreciating and looking at the image of Android, kindly understand from the baseline. So that we want to appreciate that, one, it is resting on top of Linux kernel. It is sitting on top of Linux kernel. And as soon as it sits on top of Linux kernel, it is able to enjoy and draw the advantages and capabilities found in Linux. So this Linux kernel is where this Android rests on top of, and that's the device drivers. We also have the Android runtime, a very, very important component of an Android architecture, where we have Dalvik virtual machine. The same way we have Java virtual machine. In the other class, we talked about JVM. Yes, before I proceed, is there any question?
In the qualification software engineering?
I think it's a concern from Francis. Yes, Francis. It seems you're talking. Please let us know. You have an issue? Francis, you have an issue? Jenga. If you have no issue, you can proceed. So I was talking about Android runtime, and I said that similarly, the way we saw Java virtual machine, so that you realize that Java programs the same way. Remember, I said in the inception part, I introduced and said that again, the language that we use to write this Android application is Java. And you can see from this architecture, we are also introducing something known as Dalvik virtual machine. And I say this virtual machine works exactly the same way as the Java virtual machine. You see? Just to take you a little bit on Java virtual machine. In Java, you discussed that all Java programs are actually running inside the JDK, or what we say Java Development Kit. And we say that what makes Java platform independence is the way the JVM interprets the Java code, so that you realize that as soon as you compile the Java code, it is changed to, from the source code, it is changed to Java bytecode. So the Java bytecode is interpreted by the Java runtime environment. what we say the JVM or Java Virtual Machine. So this Java bytecode is now what is executable, and that's what makes Java platform independent. The same way, similar scenario is replicated here in Dalvik Virtual Machine. It is an optimized version of JVM, but specifically designed for Android runtime. So once you write the code in Java, remember I said the language you're using here is Java, but it's not limited to Java. We also have Kotlin and the others. So once you compile, it is changed to a Dalvik executable. So once it is in Dalvik executable, that is what you can now execute. We'll later on see that. There's also a section on native libraries, which you have media, SSL, FreeType, SQLite, OpenGL, and graphics. And as the name suggests, SSL, for example, is a secure circuit layer for maintenance of security for purposes of when you're doing connection, ensure that there is provision of security. There is also SQLite, which is a lightweight kind of a MS, that's a lightweight kind of an SQL database. So the SQLite is for purposes of storage. There is also application framework. Each of these application framework, in a sense, supports the individual applications above it. You see? So all applications actually are supported by the application framework. So that in application framework, we have activity managers, content providers, resource managers, window manager, view system, and location manager. All these application framework supports the application on top. So all those applications, WhatsApp, Messenger, and the others. If you have a message app, if you have a banking application, whatever you have installed as an application, which is sitting on top of this Android architecture, actually is sitting on top of application framework. Application framework is supported by native libraries and Android runtime. And all those ones are sitting on top of Linux kernel. So we have appreciated the Android architecture, and we have understood mainly that the art of Android is actually Linux. And we have agreed that Linux kernel is responsible for issues on drivers, power, memory, and the others. The normal conventional functions that we draw from any other operating system is what now Linux is bringing in to Android. We have also native libraries responsible for browser support, SQLite storage, media for playing and recording audios and videos. We have also agreed on Android runtime, and I said within the Android runtime, we have core libraries and DVM, or what we say Dalvik Virtual Machine, responsible to run Android application. And I say DVM is like JVM, but now it is only optimized for mobile devices, you see? So consuming less memory and providing fast performance. Otherwise, it is the normal JVM. Then Android framework, which provide class and interfaces for Android application development. The same Android, when I say class and interfaces, I mean the same classes and interfaces you have in Java. Previously, you talked about Java packages and interfaces. Inside the packages and interfaces, you must have learned about the necessary classes and interface, and you must have said interfaces are the contract between the class and the outside world. So of course the classes are now the ones which contains the objects, while a package, as you said, is a namespace for organizing classes and interfaces together. And you know how to name packages and interfaces at this stage. So that will be very important as we go ahead to write the programs. And then the last part was applications, which you saw. So that is it. So the next session, you require to install an Android Studio. And just to appreciate, once you install the Android Studio, you are able now to it gives us an opportunity to be able to write a program. And that program, once you write, is actually stored in form of .apk file. And that is what is executable. So once I share you the APK file, you can execute and install and run. And that's what you actually run, the APK file. So whatever applications that you've been downloading, actually you are downloading the .apk and you execute and run. Now this takes me to Android building blocks, or building blocks of Android application. So any other Android application, as I said, for example, in this scenario, we are using Java. So Android application is coded in Java and compiled into a single distribution package known as APK. And I said the APK is what you install, what is executable. So if I share you an Android application, actually I'm sharing you the APK file, which is executable file. So what is the building block for this APK, or what we say an Android application in that sense? So any other Android application must have activities, views, and intents. It is a must for any app at basic level to contain activity, the user interface, or views and intents. Other support components of building blocks is the services, the content providers, and broadcast receivers, especially when an application needs to communicate with another app. That is when you bring in these other building blocks, like services, content providers, and broadcast receivers. So maybe you can just appreciate these components of an Android application. So as we have agreed, at basic level, we have activities, views, and intents. So what is an activity? So activity, views, and intents are the main building blocks. So what is an activity? An activity is the first Android component you encounter as soon as you power up an Android app. So once you power up an Android app and you are taken to a login screen, that is an activity, a login activity in that regard. You see? So every other screen in an application is an activity. So even after you have logged in an app and takes you to another section, then it means it has loaded in another activity. So every other screen that you see in an Android app is an activity. So an activity will always have a user interface. So every other point of interaction is an activity. So any other Android application has one or more activities depending on how many screens it can load. So, but the activity that loads first when you power up an application is regarded as the main activity. So that first activity, for example, I power up on a WhatsApp. If I power up WhatsApp, it takes me to a particular section. And that particular section takes me like chatting. That chat becomes the main activity. Then status are now sub-activities. So each of these activities has its own independent life cycle. Of course, we later on see the activity life cycle or process powering up or coming up with these activities. Now, every Android app has a manifest.xml where all activities are defined and where the main activity is also marked. So within the Android manifest.xml, later on, once you write the application, you will know what we mean by this Android manifest.xml. So when I say every app has a manifest file, or every Android app must have its own manifest.xml file. So inside this manifest.xml file is where we now define which one becomes the main activity, which one loads when we power up the application, or which one becomes the presented activity as soon as we power the application. So you need to just appreciate that activity is the Java file where you write the logic. So that is it. So every other part or every other application, once you write a Java app or one, you come up with an activity, So an activity is a Java file where you write the logic of the program or your code. We'll be able to see this in detail. The other thing you need to take note is views. Remember, I said the three important components are views that must be contained in any program or in any application in Android is activities, views or interfaces, and intents. So what is a view? So what the user sees on the screen, that is regarded as user interface or view. So remember, these things are interconnected. Every activity, remember I said, whatever is presented on the interface is regarded as an activity. So each of the activity has a responsibility to set the user interface for the screen. So every activity is associated again to a view. So UI, or what we say user interface, comprise of two types of sub-components, the views and layout, sometimes also known as view groups. So the view is the basic building block, like containing the buttons, the labels, the input boxes, and the layout on the other end is the container for view elements, which all is buttons, labels, inputs, and the others. Now, these layouts define the pattern in which the view element should show up. For example, linear layout mandates that the view element inside it either stack up horizontally or vertically. Remember, I said layout is the container. So when I say linear layout, it means now the container can now can arrange the components depending on how relative it is to the layout. So linear layout, view elements inside it stack up horizontally or vertically, while relative layout, view element position itself relative to the parent or the sibling element. So distinguish between the two layouts, the linear layout and the relative layout. So that linear layout dictates horizontally or vertically, while relative layout, view element position itself relative to the parent or the sibling element. So can understand the two types of layout, the linear layout and the relative layout. You will be using this when we'll be setting up the design of an application in Android Studio. So that is it. So this is an extract from an XML file. So you can see how it is. Layout width dictates the width, height dictates the height, match parent or wrap content to fill the content or fill the entire. So it can dictate whether it's match parent, wrap content, or whatever on the button, whether the content should fill the contents of writings like login, for example, should fill that button login, that's wrap content, and then like that. So you should be able to see that. The last part of these mandatory components, as we have discussed activities, we have also discussed on layout of views. The last component here, a building block that you must have, is intent. So intents allows you to move from one activity to another. That is, in simple sense, moving from one screen to another screen. So on a user interaction, for example, you are clicking a button or clicking a notification item, for example, a notification of pop-up from your phone. You might be in another application and you realize a message is just coming in. That is a notification. So intents are used to be able to facilitate such function as notification. So it is possible to pass data including an whole object with intents. So with intents, generally, as I have said, allowing you to move from one activity to another activity. So using an intent, you can also open another Android application. You see, apart from launching an activity, intents can also launch service. Remember, services were other components. You see? So with activity, views, and intents, you can create a basic Android application. So we can agree that the basic and must building blocks of any Android application is activity, views, or we can say layouts in that regard. So you can say activity, views, or intents. So those are the three building blocks of any basic Android application. To display, for example, a low wall, you need activity, views, and intents. Now, let's discuss these are the last bit, that is the other added components, which is not a must. So services, content providers, and broadcast receivers, which in a sense supports the other ones. Now, as services, as teaser, it is only allowing you to be able to do other services as you are working on the main activity. For example, at the same time I can be listening to a phone, same time I'm chatting, you know. So this is using achieved using services. So services in Android is a way of keeping an operation going on in the background. So when you need to have a long-running task like playing music, downloading, achieved through the same service, you don't, in that sense, you don't need to have a user interface to do those. Sometimes you might be downloading, sometimes again chatting at the same time. So services allows us to be doing such tasks. So to show a user or to inform a user about a service, notifications are used. So that's why you can see something is progressing, like downloading at a similar time you're working on some other application. So there are two ways you can create a service. One way is to tie the service with an activity. So you can tie a service to an activity. You see, very important. So you can see all these things. Again, you can see from intents, we said apart from launching an activity, intent can also launch a service. So you can see these things on other components work with the others in other sense. So again, services can also end an activity or stop an activity. The other way, you can run a service, again, independent of an application. So if you run a service independent of an application, it means that the same service can keep running in background even if the application is stopped. So it's important to note that. There's also an aspect about storage, SQL database, which you can read on that. Content providers. So these content providers is a mechanism to allow you to use data from another Android app. You have an app and you want that app to use data from another application. That is what we use content providers for. So content providers simply allows you to use, for example, contacts and SMS. Those are two different applications which works with each other. So they use content providers so that you can draw the numbers which you want to SMS like that. So a good example for content providers. These are notifications. You can read on notifications. The last component is broadcast. The last building block in that regard is broadcast receiver, which is a way to listen to system-wide events happening in your phone or tablet. So you can listen to events that are happening in your system or in your phone in that regard using broadcast receivers. So like a very good example is there's this the ones which you normally use to check the true color. It works very well on utilization of these broadcast receivers. So when you call, for example, it is able to detect who has called, you know. So it's a very good, important example of an app which is actually using broadcast receiver, which is a way to listen to system-wide events happening in your phone or tablet. That's the best. I can give you an example on broadcast receiver. So that is it. So unless there are any questions, I hope we have appreciated the main building blocks of Android application from here. You know activities, what it does, and kindly read so that you can be able to distinguish the applications. The main building blocks of an application: activity, views, and intents. And the others, services, content providers, and broadcast receivers. So kindly distinguish the building blocks of an Android application. And also, we have been able to see the Android architecture. So kindly make sure you have understood these ones. I'll be able to post on the forum discussion so that you can allow you to think and understand this in detail. So with that, unless there's any question, I would want to end my session at that, unless there is a concern or a question. Yes, members.